Right, so here we've got question 3 from the CWC, where you were given this function f of x and asked to show that the derivative function is equal to this here. So if we look at the original function, you can clearly see it's a quotient. We've got 4x plus 1 over x minus 2. So we're going to use the quotient rule to solve it. So the first thing I'm going to do is define the numerator as g of x and the denominator as h of x. So g of x is here, I differentiate that to get g dashed x, and h of x I differentiate to get h dashed of x. And then I can look in the formula book to get the quotient rule. So this is what you're given in the formula book. So you can see we take the derivative of the numerator and multiply it by the denominator, and then do the same to the other side, and this time find the difference between them, and then divide by the denominator function squared. So if I substitute everything in, then I should get this function, and you can just pause the video and just check that you're happy where that function comes from. So this is the derivative, but you can see it doesn't look quite right yet. That's what we're looking for. So the bottom is fine, the denominator is correct, but just need to play around with the top. So if I expand the brackets, I get this function here, and then you can see the 4x's cancel out, and we're left with minus 9 at the top in the numerator. So that's all good. So that's part A. Then in part B, we were asked to find the coordinates at P, given that P is a point on the function, on C, on the curve, where the derivative is equal to -1. Okay, so I need to make the derivative, which we know is this function here. I need to make that equal to -1, and then I can solve that equation to find x. So the x is in the denominator. First thing I'm going to do is multiply through by the denominator. Negatives on both sides, so I can cancel those. And then I just need to expand the right hand side and move everything across, and I get a quadratic equation. And you could use your CWC calculator to solve that quadratic equation. It factorizes quite nicely anyway, so we end up with solutions here of 5 or -1. However, if you look back at the question, you'll see that it states the domain of x as x being greater than 2. So we need to point out that this is not a possible solution for our function. Okay, so to get this accuracy mark, you do need to have stated both of these, but then discounted this one, preferably with a reason like I've given there. So this is our value of x, but if you look at the question, we're asked to find the coordinates. So I've now got to find my y coordinate, so I need to substitute this back into the original equation. And be careful, don't substitute it back into the derivative. If you do that, you're just going to get the answer -1. We already know that. So you need to substitute it into the original equation, and that gives us a value of 7 for our y coordinate. And so these are our coordinates, and if you write them as coordinates, you will get that next accuracy mark. We can check this one, and to do it we can use the derivative function on our calculator. So we can say the derivative of our original function when x equals 5. Well, we know that that is at this point here when we think that the derivative should be -1. So you just need to check when you put that into your calculator that it gives you -1. And that's it for question 3. I hope it explained it well, but if not, go along to a subject extension for more help. Thanks.